All right, hi, thanks for joining me today. My name is Danicka Oglesby, and I'll be going over a little bit how I use Houdini to create content and then bring it into my game engine of choice, which is Unity. So just a little bit about me, as I'm a very recent intern from SideFX, actually. I'm currently based in Austin, Texas, as sort of a general technical artist. I like, getting my fingers in lots of different areas of pipelines, and so I don't mind figuring stuff out. And I went to Texas A&M for visualization, which is their graphics program, and it's very technically inclined, and it's where I got my, CG start. So my internship was very specifically a games internship, which involves using Houdini tools for Unity and Unreal. They want to show that their game dev tool set and Houdini engine. They want to make demos of that, and that's what I was primarily there for. And then I ended up making several workflows. So for instance, later you'll see my crowds workflow, how I create crowds in Houdini, transfer that over into Unity, and what kind of things I ran into and how I resolved those. And I'll also be looking at assets I created for my VR environment and sort of looking under the hood at those different assets and then how I imported those into Unity. So when I first got to SideFX, they let us pick a personal project we wanted to work on, and then they had a list of game workflows they wanted to see developed. And so my manager, Paul, had like a list of ideas that they wanted to see, and he got to crowds, and I really like crowd simulations, flocking simulations. I'm really fascinated by those. So I was like, yeah, I want to try crowds. I want to try my hand at that. And I really wanted to make a VR music-driven environment because of all the Houdini projects I've worked on, the ones that were driven by music were by far my favorite. They were the most fun to manipulate. So I put both of mine into one project. So in my singular project, it's a VR environment with crowds in it. So since I wanted music-driven environment, I wanted something that had a very distinct visual and musical style. So I picked Synthwave style, and SideFX was great, and I had complete creative control over what direction I wanted to take things in. They just stepped in to help out with like technical aspects that I was running into. But as far as look and how trippy everything was, they let me just go crazy with it, which was awesome. So here I have a video of my VR experience from start to finish, and let's see, there's no music in the first bit, but it'll start to kick in, hopefully. There we go. Yeah, thanks. So it was a 9-week project, solo project I did on my own. And a few notes about this animation is like the song isn't instantly interchangeable within Unity itself. It does require a little bit of finessing in Houdini to get the song switched out, because a lot of things I built around the song itself. So there's no gameplay mechanics because I didn't want to spend that time, figuring if anyone should be doing anything. So it's just an environment and an experience that people just sit in for about a minute. And then I wanted to point out that the models and animations were not done in Houdini. I got those off of Turbo Squid by this awesome guy, and they worked perfectly for my purposes. So I'm going to look first at the animated environment I made and what things I ran into with that. So first, when I was thinking about my animated environment, I had to have sort of a plan because I knew crowds were going to be walking over it, and I knew it was going to be surrounding the player. So I thought, it's a 9-week project. I'm by myself. I don't want to have to populate things sort of out on the horizon. So I sort of wanted a bowl shape to keep the horizon out of view, so I wouldn't have to create assets to kind of fill in that area. So if they can't see it, I don't have to put anything there. And I also knew I was going to have crowds walk down around spheres and through pathways, so I had to model the environment with that in mind. So here is a video of my process on how I create my environment. And I start out with a flat grid, and I put in different attributes with Vex. I use quite a bit of Vex when I'm working because I love the control that it gives me. So I have all these editable parameters that I can go in and mess with, but we'll look at that later because it won't come in until the music part. And then, so when I was looking at Synthwave reference, I saw like a lot of the mountain environments just looked like a mountaintop in Houdini. And so that was one of the reasons I picked Synthwave. And so what I actually do is how I mesh between the two is I take the grid, I take the mountain, and since the points are 1-to-1, they directly correspond with each other. I adjust how far the base grid point moves towards the mountain point. So I can control the environment here, basically how close the grid point gets to the mountain point through Vex, through use of distance-based parameters. And, it's a vector between the main point and the mountain point, and I either push it to the mountain point or past the mountain point or in the negative direction, and I control how, noisy and how big that looks. And then I flatten out the middle area for the player. And so I knew I needed pathways for my crowds. So I'm looking at the pathways. So I model out procedurally just 2 really basic pathways. And from that, I use a group node, and I'm able to group out those points on my base grid. And so I say, I don't want these points to be affected by the mountains. I do want it to be affected by the overall bowl shape. So with that, you can see those clear hills where there's no mountains, and that's where I planned for my crowds to be walking on. And so everything's done like very procedurally, so I can move the roads if I need to, up, down, left to right, whatever is going to look better for my game, and I can adjust those pretty quickly, without having to, adjust individual vertices or faces or anything like that. And then comes, let's see. Move on to music next. Yeah, so here I go on to analyze music, and I analyze it through the CHOPS network. I followed a tutorial that showed me how to extract music data and use it on geometry. And here's the motion effects view. And I've got 3 different music pieces that I've analyzed. I've got, a bass level, a mid-tone level, and a treble level, because I wanted the different areas in the mountains to be manipulated by different tones. So the innermost mountains are affected by the treble tones. The outermost mountains are affected by the bass, just so it gives it some, dynamics, some variation, and they're not all moving the same, but they're still all being driven by the same song. And here's a bunch of Vex again that applies the music to the mountains how I specifically want. You might not have to get that fine of control over it, but that's what I enjoy doing. And so here we go back to the overall controls, and as the music's playing, I'm able to sit and adjust parameters while I'm watching it to get the correct feel that I want, to get the correct look that I want, and make sure, like, if it's too pointy, I'm bringing them down, or bringing them up. So it's all, and being very procedural is important because I made a lot of adjustments over time to get to this point. And so now I'm having to think about how I export it. How am I going to get it into Unity now that I have it? I have it blocked out into quadrants, which I'll showing now. So each one of those corresponds to a different quadrant, because I'm working with about 10,000, vertices. And that's going to be a lot for what I want to export it with. It's the Game Dev Toolset Vertex Animation Exporter, and that allows me to get it into Unity. But since I had so many vertices, it was a lot to handle. So I blocked it out in quadrants, and I just imported each quadrant, and that worked really well. And here's a look at the tool really quick. But my next slide, I show how I actually bring that into Unity after I've exported it out. So you just fill in, what you're exporting and normalize it to 0 to 1 space so it's a little more accurate. And it exports a mesh and it exports a photo. And it reads from the photo to animate your vertices. So based on the RGB data is how it moves your points around in space. So I import the mesh into Unity. And so the shader I'm using is from the Game Dev Toolset GitHub. And so it's a quick look at the shader on Git and GitHub. And then it's imported into Unity right there. So I'm just kind of like highlighting, like, here's the shader. So how I put that on is I just throw on a material, brand new material I made, and then I change it to the vertex shader. And there's different texture areas, and that middle one is for the position texture. I don't have a normal texture, so I just leave that blank. So I've put on the position texture, but nothing's happening because you need the bounding box min and max from the Houdini shader output, and then you input that into Unity. So I'm just copying and pasting those values to get it to move. And one note about the textures is that they have to be divided by 100. Then that's the conversion from Houdini to Unity, or else it's going to be really big. So I'm importing those numbers and just moving the decimal over 2 times. So it's moving, but it looks really strange. It's not how I want. So the speed and the number of frames has to be adjusted to get that to work. So first here, I input the number of frames, which is 3,149, I believe, but it's still really weird and too fast. So I have to adjust the speed. And the speed is the frame rate divided by the number of frames you have. So my speed, is that number. I input that in, and after that, it starts working normally. After all that, it finally starts animating with how I expect with the music. And I just do that 3 more times for each quadrant, and it comes in as my environment, and it's 1-to-1, works perfectly with the crowd simulation. I worked with it, and there's that. So a little bit on the shader I used. Notes on the SideFX Shader. It's on their GitHub, and you have to dig a little bit to get it. And I use a soft body shader because my topology isn't changing. And there's different shaders, like if you have a fluid simulation, your topology is changing. There's like if you're using points and particles, and a couple of notes that I already pointed out as I was showing you. But the shader I used was a little bit different. I didn't want to use, the fragment shader or the coloring of SideFX Shader, I found a wireframe shader that I really liked. And you can use a texture with SideFX Shader, but I thought with all the movement, it'd get really distorted and the texture wouldn't look that nice. So all I had to do was I took a shader I liked, I replaced the vertex calculations of that shader with SideFX's, and it worked perfectly. And so in this shader, that orange box is outlining the Houdini part and the SideFX part, and it's the exact same from their shader. So I'll be talking about some of the minor assets I put in. And so these two assets here, I just rendered out as render textures and put them on to different geometry I had. And so this kind of details how I did the sun Boolean texture. It's a bunch of boxes that I spawned, and they raise over time. They get smaller over time. They disappear over as I get too small, and I move them around to make sure they're in the center so I can get a nice flat camera shot. And I put a gradient on them to get that orange to pink color. And that's something I probably should do in Unity, so you're able to customize the colors after you've rendered it out. But this is my approach to it, and it looked fine, so I didn't think I needed much of a procedural approach since my first try worked fine. So I use those boxes as sort of a Boolean on a grid to get that flat render texture, and then put that color on it and render it out. And since it's looping, I only needed to render about 20 frames, and I just looped it over and over in Unity. I just applied that to a circle in Unity. I animated the circle going around the player, so it's kind of like sunrise to sunset. But some trouble I had with the video is Unity, because I wanted that alpha channel so you can see through it to like the sky in the background. Unity only natively supports alpha channel in their videos in WebM format, and I'm working with Houdini and rendering stuff out and After Effects, and I was having trouble like getting that WebM format. So I just customized a shader, and I said, if there's black areas, just make it transparent, and that worked just fine. It was a lot less hassle than trying to convert it to WebM and get it back into Unity. So another render texture I worked with is this sort of the pulsating ribbons in the background. They're also being driven by the same music analysis I showed you earlier with the CHOPS network. And so how I did that is I just have a cylinder with points. I wire into a pop network, and only one row is music driven. And what I wanted was to have a sort of ripple effect. So the one row would move up and bump the points up, or move down and kind of bump the points down. And that's being done with a pop interact node. So the interact lets you like push points around within the pop network. And the only forces I have in there is it forces the points to kind of go back to their starting position until they're pushed by their neighbors. And after I have those points, I sweep a grid around it just to get that nice banding, just those nice stripes. And I put a 360 camera right in the middle and rendered out a 360 texture of it. And it looks like this. And now I look at it, I was like, oh, I could have done that just like flat, like I did with, the sun texture. But this way it, makes sure that the ends will meet each other when it's finally applied to my spherical object. And then I adjust the UVs in Unity so I can, get a good idea, get a good placement before I export the half dome into Unity as an OBJ or FBX. And then similar to the sphere or the sun circle, and just a custom shader that takes in the video and sets a black part to be transparent, because I still want to see that nice sky space background. All right, so those are my geometry assets, and the second part of my internship was this crowd simulation. How do you get crowds out of Houdini into Unity? What does that look like? And the direction I was given was you can write crowd data to a CSV file. And so I took that and I played with some options, and this is the workflow I came up with, and we'll be looking under the hood at that. I have this tool packaged as an HDA. So it's kind of, I like things to be very plug and play for different people, but I'm still going to be looking sort of under the hood at how I did all that. So I have a very basic crowd simulation. If you notice, they're like running, they're walking, they are resting. There's different animation states. And so when you first make a crowd simulation, it's not ready to be output as a CSV file, because if you see here, it has all this data that we don't need. It's not necessary. And that's going to be all written to the CSV file unless we get rid of it. So I just, go put a asterisk and say, get rid of everything except these parameters. And as you see, getting rid of them doesn't break the crowd simulation. Everything's working fine. But if I export the crowd simulation as is, like, can I pause it? Okay, if I export the crowd simulation just as them as individuals walking around, it's only going to export, the frame you set it at. So it's only going to export that one position. So I use a solver in order to record their history. So the solver can take the previous frame and the current frame and make adjustments based on it. So if you see them walking, they're leaving behind a history of themselves. So I have that history in the CSV file, so I can move them at runtime over time. So I record their ID and their age, and I use that to move them around in Unity. So it's very important to have that history. And you can adjust how often they leave a history of themselves. There's a resolution value I put in. So if you want, more history, or less history, you can adjust that value. I found that, recording every 24 frames, one position, that works perfectly fine. So once I have all of that, so we've gotten through the solver, and that's just a quick look at how simple the solver is. It just saves every number of frames, and it's 4 nodes. So once I have that, so I'm writing out as a CSV file. So when I get to Unity, I have to worry about how I'm going to parse that data in and analyze it. So I sort my whole file before I export it by age and by ID, because I know I'm going to use their ID and I know I'm going to use their age, because I have a custom agent struct, I have a locomotion script, and having their age and ID already sorted for me before I have to worry about it in Unity helps out a lot. And so, and this just takes a look at the CSV exporter. This is a game dev tool. It just takes whatever you put in and it exports the geometry spreadsheet as a CSV file. And that's how I export all, the position of each agent, the orientation of each agent at what age. It's like how, if he's 2 seconds old, what's his position, what's his orientation, what's his animation state. So this is kind of my workflow, what I just described, simulate it out, strip out everything you don't need. Solver records the history so we can have that in runtime at Unity. Sort it for easier parsing, and I use the game dev CSV exporter. So when I import it into Unity, I have this information and I had to think, okay, how do I use this once I get into Unity? So this middle load data is sort of like my master parser assignment script. So I put in my CSV file and whatever game object I'm using as my agent, I put it as an input, and my load data script, it applies an agent struct to each agent and populates it with the CSV data. So it takes agent 0 and it, populates it with positions and its orientations and animation states. And then my locomotion script, it attaches the locomotion script to the agents, and that's what actually reads the CSV data and determines what position it is in the world and the orientation, and it triggers different animations. And yeah, so sort of like, my workflow on that and how I figured all that out and got that to work. So here is a video on how I actually import that into Unity. So I loaded my CSV file and I've got this load crowd prefab already put up because, as I said, I like things to be very plug and play. So I put in my CSV file, my mannequin object, and I just hit play. And at runtime, I've got my little crowds, my little guys running around. And they're going through their different animations. They're walking, they're running, they're resting. And I'll get into how I have their animations, how I get them to animate like that. Because normally when you save out a crowd simulation, it's a lot of information. And I fake the animation to kind of get around having to export all that data out. So now what I do next is I just quickly switch out the CSV file with something different. I have some more geometry that I put into my prefab as well. I made it to where you can have multiple different objects and you can adjust the ratios and, you know, how often do you want these people to show up. There's another functionality where you can, you know, specifically set certain agents to certain objects. So here I just have, this is the CSV file for my project. I've got cylinders and spheres and cubes and tiny, tiny little agent guys that are being moved around by this script. And so I tried to make it fairly robust. Yeah. So when I was showing my export process, I say I save every X number of frames, save out a guy, an agent. It's like, okay, well, I want them to move smoothly throughout the game. And the reason I only save certain frames is because, you know, it saves on, you know, size a little bit. And also you can only save up to a certain, you know, fineness of resolution. So why not just save it every 24 frames instead of every like half frame or something like that? Because it's going from, you know, 24 frames per second, like you're used to seeing movies, and then you're coming into games, which is real time, and it's got to be basically continuous all the time. So the locomotion script I was talking about just does linear interpolation between positions. And I say rotations, but you don't do linear interpolations with rotations since they're quaternions, but it's just interpolation between the two states. So you have state A and state B, and you have a timer, and the timer looks at the age, and there's calculations that does linear interpolation to say, okay, so, you know, between point A and point B, they should be about here. And that's how it moves smoothly across the screen. And then triggering the different animation states works in the same way, except you don't need to interpolate between that. It just gets to a new animation state and it says, okay, turn that animation state on. Okay, turn that animation state on. And I have this little graphic that kind of shows, you know, you've got the pink agent at point A, blue agent at point B, and then all the calculations determine where he is in the middle between those two states. So I have an HDA for convenience, said it a couple of times, and I made all my scripts, everything into a single Unity package, and all you have to do is drag in that load crowd prefab into your hierarchy, you throw your CSV file in, you throw your game object in, and you hit play, because I want it to be as like user-friendly as possible. So how I fake the animation, because without the animation states, you put your game objects in, it looks like they're sort of on a conveyor belt and they're not really moving, they're not doing anything. It just looks fake. So if you're familiar with Unity animations, I use the animator controller to set up transitions, to set up triggers, and I use a CSV file to, you know, read those animation states, and then the locomotion script triggers them at specific times. And then a little disclaimer is that currently, you know, you have to set up the animation controller manually. You can write a tool that'll make it for you, but manually has worked fine for me. So for the animator controller, I just have the three states, the run, walk, rest, and I'm just demonstrating how Unity, you just, you know, click each trigger and it can transition between each state. So that's essentially what my script is doing, is instead of me clicking on different state, my script is clicking the different triggers for me. So once it gets there, it just triggers. And this is a video of the script going to each different animation state when it's time. So that's how I fake the animation. It's not the actual animation that comes out of Houdini. It's just the Unity animator controller. So one more thing about my project with SideFX is they gave me a lot of not only creative vision, but they allowed me to be creative technically. So I scripted my mannequins to look at the player because VR is it's cool new territory. And looking at the player, I had a mentor that told me once it created sort of like a sense of connection with this character. But when I was thinking about it, I was like, well, if these robots are looking at the character, that's going to be a little spooky. It's not going to be like a connection. But that's something I wanted to experiment with. So people who are used to my game, I put in this script and I didn't tell them about it because I wanted to see their reactions. So I just put them in my game to see how they would react to being looked at. And in VR, it's much more visceral. It's much more, personal. And so I want to say about half of them did not enjoy the initial shock, but that's kind of what I was going for anyway. So just a little technical about that. This isn't Houdini. This is all in Unity. The model I came with didn't have, an up vector. So normally the look at how it works is it just assumes the y-axis is the up vector, but my agents are walking down spheres. So my up vector, I remember I put in my script, I'm like, why are their heads just going haywire? Well, it's because they were walking down spheres. So what I just did in Unity is I just created game objects at the base and the top of the head, and I created a vector between them, and that was its up vector, is the vector between those two objects. And then Unity has a cool function where it's called look rotation, where you just give it the up vector, you give it the target position, and it calculates how you need to rotate to look at an object in front of you. Or those are VR goggles or a player in the background. And so I just would calculate those vectors or those rotations, and I would interpolate between its current rotation and the rotation I wanted it to go to. And that's how it looks at people and looks away from people. And so that was a fun little thing I did. So that hits all the notes of my technical challenges I faced with this project. It was really fun, probably the best project I've worked on so far, and I had a lot of fun with it. And so if there's any questions about my workflow or my internship or just questions in general, I'd be happy to answer. Thank you.
Like setting up the crowds inside Houdini, is it like a separate, like a DOP network or something, or how did you do this simulation?
Okay. Yeah, I didn't touch much on like how to do a crowd simulation in Houdini. Houdini has a great crowds like toolkit, and they've got a lot of I looked at examples more than anything. They've got examples in the toolkit you can look at, but you bring in your agent, and there are certain tools. You click on your agent and you click on the tool, and it sets up a lot of stuff for you, but it's essentially a glorified particle simulation. So it puts it into a crowd solver, and you use different crowd nodes, different trigger nodes that are formulated especially for crowd simulations to transition between different states. But yeah, all in all, it's just a very specialized particle simulation. There's great tutorials for it online, but that's essentially it. And yeah.
Did you hit any performance issues during this project?
Yeah, it's a good question, because that's what I was anticipating when I came into this project was I thought it was going to be expensive because crowds are expensive. But the expense of crowds is all in the background algorithms, like getting them from point A to point B. Whereas my process just records their final destination. It doesn't actually do any of that background calculations in real time. It's only reading what's there. So the only performance issues I ran into was trying to render a bunch of agents at one time. And I know there's different tools out there to kind of get that under control, but it's not what I really focused in. But no, as far as like the locomotion script, that's the script that's running all the time. That was fairly lightweight. It barely made a dent in my performance at all. So. And if you saw a quick note, like all the agents are created as soon as you hit the play button. It can be reworked, so you can create all your agents beforehand, but you'd have to constantly like be updating them. Whereas the play button, I never ran into any performance issues just hitting play and having them all populated in like a second. So, yeah.
Are there any gotchas when you write the CSV import in Unity?
Oh, gotchas. Yeah. There. A few. There. So when I was reading it into Unity, as you said, so working with it, the gotchas I found were parsing it in. So like I said earlier, I said, oh, I do this so it parses easier. I do that because it parses easier. That was the main gotchas is I was like, oh man, I need to go back and sort by ID. So this is easier to read in. It's like, oh man, I need to, delete this so it reads it easier. And there's a little checkbox on the CSV exporter called, it's like export, like, I forgot what it's called, but if it's like export variables like XYZ as their own columns, because if you don't check that box, it'll export like the point in one column. So you have to like make your parser more robust to be able to like call out parentheses and commas and get that information out. So that little checkbox was very important. So it just put XYZ in different columns and I wouldn't have to worry about taking out parentheses and commas and all that stuff. But yeah, that little box is magic because once you just have everything in separate columns, it's so much easier to parse back in.
Yeah. You just create the number of square meshes that you needed in Unity and put them where the CSV can go.
So, sorry, say that one more time.
So the process of the script, do you just create, for example, if you have 50 agents, you just create 50 skeleton meshes and move them to where the CSV file tells them to go? Right.
So that was why the ID of the agent was so important because I might have 1,500 entries, but I might only have 15 agents. So my parser, it goes through and it looks at the number of unique IDs and it creates those unique agents based on the number of unique IDs. And then it takes the very first position and that's their starting position. Yeah.
Thank you.
Have you experimented with taking any other types of simulations into Unity, like for real-time stuff?
I have. At very beginning, I was experimenting with my music visualizer. That's the word. I was eventually thinking of it as points, as I was going to do like sprites of birds or something. And again, it was their vertex animation textures. They have one specifically for points. But there's a great demo. I want to say Louise did this demo in Unreal where he shows all the different shaders being used. Like one's a cloth sim where they drop it on top of a pig head and then they export it into Unreal and you can see the cloth taking the shape of the pig head in Unreal. And then it shows like changing topology of like a pyro simulation, and that's done with vertex animation shader. And I think that's how they're handling their simulations right now is with those vertex shaders. Yeah.
Thank you.
Yeah. All right. Well, thank y'all so much.